Let's go. Linear algebra. Let's do it. Anki. That's where we start, is Anki. This is day 36 in a row of Anki. Good streak. What is a homogeneous linear system in the variables x1, x2, xn? a1 times x1 plus a2 times x2 plus plus ax or an xn equals 0. Suppose that A is an m x n m by n matrix and x is a n by 1. Express ax as a linear combination of the column vectors of A. All right. Column vectors of A is basically going to be, there's m rows, so it's going to be like x1 1, no, lowercase a 1 1, and then below that's going to be a 2 1, a 3 1, a 4 1, a m1, and then that structure is going to be very similar across the next one. It's going to be 2 1. No, it's going to be 2 2. No, it's going to be 1 row 1. It's going to be 1 2. 2 2, 3 2, 4 2, m2, and the next one's going to be whatever. It's going to go all the way until the last column vector is 1n, 2n, 3n, all the way bottom, it's mn. Okay, and then each of these column vectors are added together, and each of them are multiplied by, the first column vector is going to be multiplied by x1, or x1, the second column vector is going to be times by x2, and the last column vector is going to be times by xn, because there's n rows in the column vector. Killed it. Let's do it. Got it. What is the column row expansion of a matrix product AB? The column row expansion, so this is where you take a column of A, times it by first column of A times the first row of B, plus the second column of A times the second row of B, plus the say n column of A times the n column of B. Expressed it, I said it differently, but it's the same idea. If a linear system has infinitely many solutions, what is a general solution of that system? Now, if a linear system has infinitely many solutions, a general solution is a set of parametric equations in which all of the solutions can be found by plugging in values for the parameters. So the parametric equation which also should be attained by assigning numerical values to the parameters. Pretty solid. What are the coefficient matrix and augmented matrix of a linear system AX equals B? Coefficient matrix is going to be A. Coefficient matrix is just A. Augmented matrix is going to be A with a line dividing it, but that's not exactly necessary, so AB, but not times, like A and B. All right. Oh my gosh, this could be the last one. What is the size of an augmented matrix of a linear system of m equations and n unknowns? The size of an augmented matrix with m equations it's gonna be m by n plus 1. All right, there we did it. Craziness is that since I started using Anki in July 2023, over 2 years ago, I've actually learned on 43% of the days. How? That's crazy. Considering that, like, I went for month hiatuses multiple times. All right. Yeah, I originally did it for myself, then I did it for my first semester in college, then I did it for my second semester in college and my third semester in college, and now I'm doing it on my own again. Cool. I did a little bit here and there on my own as well for guitar and for self-learning books, or reading books quickly with Anki and ChatGPT, but I'm way out of the realm of what we're talking about. I'm gonna grade what I did yesterday, and then I'm gonna continue working. So after I grade my problems from yesterday, I'll jump back into doing more practice problems. All right, guys, you're not gonna believe this. I did all of this right, except for I freaking added 1/2 plus 1/2 and got 1/4 instead of 1. I think I just was like, there's no way I did this right, and then my brain turned off or something. But I literally had everything right. I canceled everything out that was important to cancel. I got 1/2 plus 1/2, and I put 1/4. If I would have put a 1, like 1/2 plus 1/2 is, I would have got the right inverse. So that's annoying, but also a little bit of confidence building that I got all the other exponents and distribution and cancels out and everything right. So this one was right as well. This was finding A when you're giving this statement. So, all right, I'm gonna jump into more practice problems now. All right, we went back and did one little quick problem from 1.1. Took like 10 seconds because it was asking for a single elementary row operation to get a 1 in the top upper hand left hand corner without creating a fraction in the first row. Extremely easy. 1.4, this was evaluating for P, like the polynomial matrix. So I think this is what they're asking for. Like, this is fully simplified. So we'll go ahead and check if I know how to do this tomorrow. I think I times it by the identity matrix. I think that's what you're supposed to do. And then just plug in that for X, the matrix for X. So, and then, yep. And then that's all we got to. So, that's going to be it for today. I'll talk to you tomorrow. See ya.